Okay, so we worked a problem like this in class, but I wanted to give you guys another example. In this problem, we want to calculate the percent by mass of chlorine in C6H3Cl3. So we have a molecule that has 6 carbons, 3 hydrogens, and 3 chlorines. And we want to know how much chlorine is there by mass. So to do that, I've already taken the liberty of writing the molar masses of carbon, hydrogen, and chlorine on here. Now, you can shove all these numbers into your calculator at one time to get the molar mass and then go from there. But I like to write it out systematically. So, we have 6 carbon atoms. So it's going to be that value times 6, and I'll come back in a second and pick up my calculator. We have 3 hydrogens, so it's going to be the molar mass of hydrogen times 3. And we have 3 chlorines, so it'll be the molar mass of chlorine times 3. Not sure if it's easier to see it with parentheses around that. Doesn't really make any difference mathematically in this case. Okay. The reason I'm breaking them all out individually is because we're going to need the mass of all 3 chlorine atoms by themselves to solve this problem. So rather than, like I said, shove everything in your calculator, because you could do it all in one go with your calculator, but that would just give you the molar mass. So 12.011 times 6. So the mass that the carbon contributes is 72.066. The mass from the hydrogens, 3.024. All of these units are in grams per mole. And the chlorines, their contribution is 106 or 359 grams per mole. Another reason why I want to write it out sequentially like this, just by inspection, we can see the chlorine contributes the largest to the total mass, much more than hydrogen and significantly more than the carbon. So that should give us an idea that percentage-wise, the chlorine, its mass, is going to be a big percentage of this. Now, we'll get the exact number in a second. So now we add all of these up. And this gives me the molar mass of the compound. So our molar mass, our total mass, is 181.449. Now for percent mass, sloppy. We need the mass of all 3 chlorines divided by the total mass. So 106.359 divided by, I'll get out of the way for a second, I'm running out of room here, 31, 4. times 100 to give us a percentage. And when I do that in my calculator, it's 100. This gives me a mass percentage of 58.616. Based on the number of significant figures, I can actually write one last digit to give me 6 significant figures, which we normally don't see that high a level of accuracy. So 58.6165. And so that is my mass percentage of chlorine in this compound. And if we stop and think about it, again, go back to the raw numbers, the contribution of the 3 chlorines is 72. The contribution of the 3 hydrogens is 3, so that's 75. 106.359, obviously that's bigger than 75, so this is consistent, that it's the majority of the material, in this case 58%, a little bit more than 58%. The key, again, a problem like this, none of these steps is extremely difficult, but you need to be systematic. Write everything out, be explicit about the units. And one thing, just because I ran out of space, this has unit of gram per mole, this has unit of gram per mole. That means they cancel. Percentages are dimensionless numbers. They don't have any unit associated with them. So again, 58.6165 is just a number, a percentage. It doesn't have a unit of grams or moles or anything like that. So a problem like this, again, very straightforward, very useful, because this is the type of analysis that's done when you have some chemical compound and you're trying to figure out what it is. So if I analyze this compound and it's got 58.615 or 6165% chlorine, that's consistent with this formula. If I did an analysis of another unknown and it told me I had 23% chlorine, that would not be consistent with this chemical formula. But in this case, we're given the formula and we want the percentage. But it could be turned around.